All right, so last section of chapter 7, we're going to be going over solving nonlinear systems. So we have solved systems before using elimination, substitution, graphing. We'll be doing that again. The only difference is there's going to be more solutions because we can have multiple intersections, right? We're dealing with circles, parabolas, hyperbolas, ellipses. So just to kind of get an idea of what the graphing part looks like, it says how many solutions does each system graphed below have? So we're just looking for intersections, right? So here we got these two graphs. One's kind of a diagonal hyperbola looking thing, and then a circle. So this one, see how we have 2 points. Switch to my pen here. Come on. I got 2 points of intersection here and here. So this would have 2 solutions. On this one, we got intersections in these places here. So this would have 4 solutions. Here, this parabola and circle, we got 1, 2, 3 solutions. So depending on what you got going on, you could have a lot of different numbers of solutions. Just depends on how many intersections we have. So talking about graphing. So when you want to solve a system, so here would be a system here, by graphing, what we want to do is first solve each equation for y, because we're going to end up putting them in the graphing calculator. So this one, really all we would have to do is subtract the 2x over and then divide everything by a -1. Okay? Or you could think of it as, moving the y over, subtracting 1. Either way, we'd get y equals 2x minus 1. With this one, to get y alone, all we'd have to do is subtract 7 to both sides. So boom, y equals 2, x plus 1 squared minus 7. So then you would plug those into your graphing calculator, and you find the intersection. So down here, looks like we got an intersection right here. -2, -5. I know it doesn't look like it. It's not the best picture, but you can see it's kind of counting by 5s there. And then 1, 1. And again, it's kind of hard to see here, but that would be the other solution. On your calculators, it won't be so bad because you can adjust your windows. So if we look at a few examples, so again, we want to solve for y. Second equation is already solved for y. This top one, if we solved it for y, we would get y equals, subtract 3x to both sides, so a -3x plus 4.5. So now we got both equations set equal to y. Now is when we would go into our graphing calculator. And I've already plugged these first 2 in here just to save a little time. So you see the 2 equations here. We're going to go ahead and hit graph. And so it looks like we got a line and then a parabola. It's kind of hard to tell how many intersections, but I would say it looks like 1. Maybe at 0, 4.5 looks like. And then remember, you can go second graph to look at your table. So if I'm looking at my table here, what I'm looking for is these y's to match up. So not matching, not matching, not matching, not matching, and boom, right here. So they intersect at the point 0, 4.5. So this one only has 1 solution, and that's just fine. It's less work to do, right? All right, so then we get to the second one. It can be a little more tricky. So again, first step, solve for y. So on this first one, I would move the x squared over. So y squared equals 25 minus x squared. And then I would square root both sides. Remember, we square root, we get a plus and a minus. And then 25 minus x squared. For the second equation, I'll switch colors here so it's a little easier to see. So again, solving for y squared, I would move that 4 over first. So it would look like that. Then, before I square root, I want to divide by 9. So y squared is going to equal 145 minus 4x squared. Everything is divided by 9. So keep that in mind. And then, so lastly, you would square root both sides. So we're going to get plus or minus square root 145 minus 4x squared all over 9. So I'm going to go into my graphing calculator here and plug my equations in, which I have a lot because I got the plus and minuses, right? So let's go ahead and clear these other ones out. So first one, I'm looking here. So first of all, I would have a square root, and then 25 minus x squared. And then I'm going to have the same thing, but with a negative in front. Make sure you use this button or your calculator is going to get mad at you. 25 minus x squared again. Okay, and then I'm looking at these orange ones. Big old thing here, so got to be a little careful plugging it in. So square root, especially with this 9, because this is all under the square root. So on top, we're going to do parentheses, 145 minus 4x squared. And the parentheses, and then divide by 9. And then for the next one, it's the same exact thing, but with this negative in front. So go ahead and write that in there again, hopefully without typing anything in wrong. Parentheses, divide by 9. Okay, so I got all my equations in there. So I'm going to hit graph. Okay, it looks like we got, well, let's see, 1, 2, 3, 4, 1, 2, 3, 4. So it looks like 2 ellipses, I believe, is what I have going on here, if I'm counting right. Actually, no, circle and ellipse technically. Remember, it's not in the square. If you want to make it a square again, hit zoom 5. And so now you can kind of see how it's a circle and ellipse. Looks like we have 1, 2, 3, 4 intersections here. You can count them if you want. 1, 2, 3, 4, 5. That looks like 4. Looks like 4, 3, 4, negative 3, and then, or sorry, negative 4, 3, and negative 4, negative 3, and then 4, 3 here, 4, negative 3 here. Again, you can check that by doing second graph. Okay, now there's a bunch because we had 4 equations, right? So if we look at right here, negative 4, we got 2 3's and 2 negative 3's. So that means some of our solutions, we have, oops, at that negative 4, we got negative 4, 3. Showing up twice, and we have negative 4, negative 3, and then just so you can see it on the calculator again, if we go to positive 4, you see we got positive 4, and then the 2 3's, so 4, 3, and 2 negative 3's. So 4, negative 3 is another point. So these are all of our answers right here. Okay, so that's the graphing. Just set it equal to y. And look for your intersections. On your assignment, I'm just going to look for you. Did you set the equations equal to y? Good. And I'm assuming you graphed it. Next, we're going to do substitution. We've done this before. This is about getting a variable by itself and then plugging it in. So on this first one, okay, I'm noticing, okay, I got, well, y is almost by itself. I just got to add 3x over here. So I can take this guy and say y equals 3x plus 7. So then what I do is I take this, and I'm going to substitute it in for y right there. If it lets me draw. There we go. So that, when I substitute, would give me x squared. And you got to be careful, because this negative here, you want to put the y in parentheses, 3x plus 7. Because that negative is going to also go to the 7. And then equals 5. So distribute that negative, x squared minus 3x. Minus 7 equals 5. Then we're going to have a quadratic, so we have to set it equal to 0. So x squared minus 3x, and then subtract 5, we get minus 12 equals 0. Do our fun factoring we like to do. So x and x. We need factors of 12. That'll get me 3. Well, I know that, did I do some math wrong here? 6 and 2, 4 and 3, 1 and 12. Oh boy, I messed something up here. 3x, okay, yep, there's my mistake. This was supposed to be a minus. So 3x minus 7, that would make this a plus 7. So minus 5, this would be minus, sorry about that guys. It would be minus 2 here. Oops. Come on. There we go. Now it's going to work, because now we can do, or sorry, plus 2. Jeez. because I subtracted 5 from a positive 7. So this is going to have to be a minus 1, minus 2, because negative 1 times negative 2 is 2. And then negative 1x, negative 2x would give me negative 3x. So x equals 1 and 2. So I got to figure out the y's that match up with it. So I can plug in 1 here. And so that would give me 1 squared minus y equals 5. So negative y would equal 4. So y would equal negative 4 with the 1. So 1, negative 4 is a solution. And then we plug in 2. So that would be x squared. Sorry, not x squared. We know what x is. 2 squared minus y equals 5. So that would be negative y equals 1. So y would be negative 1 with that one. So when you plug in 2, you get negative 1, like that. So there are your solutions for that one. All right, next up, again, using substitution. So I can see, I can solve for y right away. So this would be y equals, we can do negative 1 minus x, that's fine. So then down here, we still have x squared. This would be plus negative 1 minus x squared, again use the parentheses, equals 25. This needs to get expanded out. And when you expand it out, so you would get an x squared. You would get plus x twice, so plus 2x, and then plus 1 is what ends up happening. I just didn't expand it to kind of save room so it's not so sloppy here. So then, so what I would have would be 2x squared plus 2x. Again, we want to set it equal to 0, so minus 24 equals 0. I can factor out a 2. And so then factor it the rest of the way, that would be x plus 4 and x minus 3. So one of our solutions for x would be negative 4. And if I plug in negative 4 for x, I would get negative 4 plus y equals negative 1. So I would have to add 4 to both sides, and I would get an answer of 3. My other solution I got for x down here was 3. So if I plugged in 3 for x, okay, well 3 plus negative 4 would get me negative 1. So those are the solutions there. All right, now this last one gets a little tricky. Here you could solve for y and say y equals negative x squared plus 5. But then when you plug that in for y, you're going to have stuff to the 4th power. So another thing you can actually do is just solve for like x squared, for example. So we could say, if we divided both sides by negative 1, that x squared would equal, so just change the signs, negative y plus 5. So then when we go to here, instead of x squared, we would just do negative y plus 5, and then plus y squared equals 25. So we're going to set that equal to 0. So y squared minus y, subtract 25 to both sides, so minus 20 equals 0. So then we'd have y minus 5, y plus 4 equals 0. So y could equal 5. Let's use green here. So y could equal 5. If y is 5, okay, 5 squared is 25, well x would have to be 0. If y is 4, or sorry, I should say negative 4, so that would be x squared plus negative 4 squared is 16 equals 25. That would give us x squared equals 9. So x would be plus or minus 3. So when my y is this negative 4, I have a positive or negative 3. Alright, so that's all I'm going to fit onto this video. We'll finish up 10.7 on the next one.